We'll now discuss the coefficient of variation and what's known as Chebyshev's theorem. We'll start with this coefficient of variation. And we're going to denote this by CV. And this is our standard deviation divided by the mean. This also works for a sample. It's just different notation. And this is usually expressed as a percentage. So when you divide, you actually get a decimal, and then we want to move it to a percent. Our coefficient of variation allows us to compare standard deviations when the units are different. So we can compare things that seem very different using this coefficient of variation. Here we have that the days that construction workers missed had a mean of 11 and a standard deviation of 2.3. The days the factory workers missed had a mean of 8 and a standard deviation of 1.8. So we're going to see which one had more variation. If I start with construction, we take the standard deviation, divide by the mean, and once again we do want to express this in terms of a percent. And when we divide, we get 20.9%. For the factory workers, we take our standard deviation, which is 1.8, and divide by the mean, which is 8. And then once again expressing as a percent, we get 22.5%. So there's actually more variation with the factory workers, even though the standard deviation was smaller. We'll now look at Chebyshev's theorem, and this is a way for us to determine how much data value falls within certain distances from the mean. And here's what Chebyshev's theorem says. If we want to know the proportion of data values that fall within k standard deviations from the mean, then it is at least 1 minus 1 over k squared, where k is greater than 1. So if we have this limit for our data, and we know how many standard deviations that is away from the mean, we can determine at least what percentage is in there. And we'll do some examples to explain this. We have a test that had an average of 73 with a standard deviation of 6. And we want to know how much data is between 60 and 86. Well, first we need to know how many standard deviations we are away. So I'm going to figure out 73 minus 60 is 13. In addition, 86 minus 73 is 13. So both of these numbers are 13 away from the mean. But that doesn't tell me how many standard deviations I am. In order to figure that out, I would need to divide 13 by my standard deviation, which is 6. And I get 2.17. So these numbers are 2.17 standard deviations from the mean. We then use Chebyshev's theorem and do 1 minus 1 over 2.17 squared. And when we do, we get approximately 78.76%. Therefore, we can determine at least 78.76% of students had a score between 60 and 86. It could be more than that, but it's definitely not less than that. Next, we want to know what range contains at least 80% of the data. So this time, I don't know what k is. However, I know when I work this out, it needs to be equal to 0.8. I can subtract 1 from both sides and get that this is negative 0.2. Multiplying by negative k squared gives me 1 is equal to 0.2 k squared. I can then divide both sides by 0.2 to get that 5 is equal to k squared. Taking the square root of 5 gives me approximately 2.24. So now I know how many standard deviations I am away. Now to find my range, I need to do 73 minus my standard deviation times 2.24, and also 73 plus my standard deviation times 2.24. If I start with the lower end, 73 minus 6 times 2.24, I get 59.56. If I do the upper limit, 6 times 2.24 plus 73, I get 86.44. Therefore, at least 80% of my data is between these two values. We'll also talk about the empirical rule, which is a special case of Chebyshev's theorem. And this only applies when we know that our distribution is bell-shaped, which we also call normal. The first thing it says is approximately 68% of our data falls within one standard deviation from the mean. Approximately 95% of the data is within 2 standard deviations from the mean. And approximately 99.7% is within 3 standard deviations from the mean. We'll go back to our example earlier about the test scores, and we're going to assume that these are normally distributed, so they are bell-shaped. We now want to know how much data is between 67 and 79. I can see that 73 minus 67 is 6, and 79 minus 73 is 6. So we are within 1 standard deviation of the mean. According to the empirical rule, this holds 68% of our data.